The second topic is graphing a hyperbola centered at the origin. But this isn't in standard form, so we're going to have to do some work to rewrite this. Now, I want to do the same thing. I want to show you how to graph this in ALEKS. So instead of doing this exact problem that I typed in the course pack, let me just change it to something that looks really similar to what just popped up when I opened it up. It's a little different, but hey, maybe I can click on the try another couple more times to see if I'm oh my goodness. Oh, it's not the same, but hey, it's close enough, right? I am going to do that problem. So instead of 25, negative 25, y squared, let me change that to x squared. Plus, instead of x squared, let me just change it to y squared. That equals 25. All I did was I changed the problem to match the one that randomly showed up in the ALEKS homework, okay? So I will show you how to work with this. Now, you want to have two fractions subtracting, okay? Now, it looks like you got a negative term adding to a positive term, but listen, we can just change the order of these two, right? Look, I can put the y squared first in the front, and I can put the 25x squared that is negative after it, negative 25x squared. The first thing that I do is I make it into, I try to make it so that we have something minus something else, okay? Because the hyperbolas, you need a minus sign in between. So the only thing that I did first is switch the order of these two, okay? Now, if you want to have a hyperbola, you need to have one on the right-hand side. Do I have one on the right-hand side? Oh, no, I don't. So I am going to divide everything by 25, because 25 divided by 25 is 1. So divide everything by 25. Now let us simplify this, okay? So the first fraction gives us y squared over 25. Second fraction, I'm going to get x squared. Okay, now, but hold on a second. I like to have a number in the bottom of the fraction. So how about I put x squared minus 1? It's okay if you just put x squared. That's fine too. But I wanted to have it in the form that both are fractions with something in the denominator. That equals 1. All right, let us find the center first, okay? Center, we can read the x and the y coordinate from looking at what's being subtracted from x's and y's, but are anything being subtracted from x's and y's? No, this is just x squared. This isn't x minus 2 squared or y plus 3 squared. They did tell us though, didn't they tell us that these are centered at the origin, right? So let me zoom out and take a look. Yeah, we're trying to graph a hyperbola centered at the origin. So we have a center at 0, 0. Now remember what to do after. First, you plot that center. We'll plot that center at 0, 0. You will now need to go find the vertex. Ready? To find the vertex, look for the bigger number in the denominator. What's the bigger number? Well, 25 is bigger, right? So what that tells us is that we will need to go square root of 25, which is 5, up or down from the center. And how did I know that we must go up or down, not right or left? Because 25 was a number under y, okay? So we go up or down, okay? So let me go find the vertex coordinates, vertex or vertices. The first vertex, now notice that we're not going to change the x coordinate at all because we're not going right or left. So the x coordinates are still 0 and 0. But when you go up 5 from 0, you are at positive 5. And when you go down 5 from 0, you are down at negative 5. So let's plot those. And again, when you are doing this on ALEKS, you don't need 2 points. You just need to do one vertex. But I'm going to plot the vertices, one at positive 5, down at negative 5. Now, the last thing that we're going to need to do is find a point on the asymptote, okay? So I'll just call it asymptote point. All right, look, we already used that 25 to go up or right, up or down for the vertices. I am now going to use this number 1, which tells us that we should go square root of 1, which is just 1, right and left from that vertex to plot the axis, the asymptote point. So look, I'm gonna go one right from that vertex. The vertex is that orange dot right there, so I'm gonna go one right and plot that point. And that is, if I connect this green dot to the center, that's how I'm going to have the asymptote of this. I can try to plot as like all these asymptote points around. So I can go one to the right, one to the left. Let me go to the other one. This is going to be one skinny little hyperbola that we are graphing. I can go one to the right and one to the left. And I will go ahead and graph the asymptote using a dotted line plotter. So the first asymptote, that looks like this. And the other one looks like this. So those are the two asymptotes. And now all I need to do is sketch the parabola. No, I'm sorry, I keep calling it parabola. Hyperbola that goes through the vertex, following those asymptotes. So I got one right there, and I'm about to have one down here. And that's it. Now let me do this same thing in ALEKS, okay? So I don't have the center plotted, but what was my center? Let me look at my note. Center was at 0, 0. So I plotted the 0, 0. The vertices were 0, 5, 0, negative 5. Let me just plot the one up at 0, 5, okay? So click on 0, 5. And now remember how many we went to the right or left. From that vertex, we go one to the right to plot a point for the asymptote. Now that's all I need to plot using my pencil tool. Now watch this. I'm going to click on the hyperbola. And they said, place the center. Yes, the center is at the origin. Click. Now the next thing they want is the vertex. To place the vertex, I'll go up and then plot that vertex. And last thing they want is they want you to place a point on the asymptote. Go one to the right and plot that point. Click, and that's all you have to do. Now that looks like a very skinny vertical hyperbola. I have that too. Now the two examples that I showed you so far are both vertical. I do want to show you a the horizontal parabola soon. Maybe the next one, okay? So that's it for this topic number 2, where you had to do some little bit of rewriting to graph a hyperbola.